It's big brain time! This is part 1 of the anatomy of our atmosphere. We all live on or near sea level, and there is obviously a reason behind why we chose to live near sea level. There are all kinds of changes in pressure. For instance, when you're higher in the air, there is less pressure because the atmosphere gradually fades away, which means there are less oxygen atoms, which means we need oxygen masks to venture onto the top of Mount Everest. The melting and boiling point also changes when the pressure is different. For now, let's just get an overall anatomy of the Earth's atmosphere by having some fun on vacation. You are on vacation and you decide to go on a hot air balloon trip. There is a special balloon that can transport you to 60 kilometers high, and you can't wait for it. The trip starts. At sea level, the pressure is about 15 psi, or 1 atmosphere. This is the pressure of all the air above. Different planets have different levels of pressure at the surface. The surface pressure of Venus, or the second planet in the solar system, is equal to 1,000 times the pressure at the deepest point in the Mariana Trench, so it's basically impossible for humans to survive deep down there. Next, as we go slightly higher, the air pressure decreases. At about 1.5 kilometers up in the air, the pressure decreases by a bit. This is a huge problem for mountain climbers, as they need to breathe very heavily. That's why it's a reason why only very fit people can climb that high without air masks. The air pressure drops to 12 psi. As we slowly go up to 5.5 kilometers high in the air, you will start to get dizzy if you don't breathe quick enough. And even the fittest need oxygen masks here, as there's 50% less oxygen than at sea level. The pressure falls even lower, to 7.4 psi. Skydivers jump usually at 3.5 kilometers up, as the air pressure will be too low up there. About half of the whole Earth's atmosphere mass is located below this altitude. The other half is from 5.5 kilometers all the way up to 30 kilometers. As we go even higher to the summit of Mount Everest, 8,848 meters up in the air, the pressure is about 33% of the pressure at sea level. Because of the decreased pressure, the molecules in the air are even more separated. This makes the melting and boiling point of water lower. 0 degrees Celsius is the temperature that water can be in all 3 states, solid, liquid, and gas. You might think this is totally made up, but that's actually true. And air pressure plays an important role in that. You cannot make tea. How sad is that? Because water melts at 72 degrees Celsius here. Not enough for good tea. Some migratory birds, such as the bar-headed geese, have to migrate all the way over the Himalayas, which is a major burden for most birds, as they can't fly over it. However, this bird has highly powerful lung power and flies very efficiently in the thin air, so it isn't a problem. At 11 kilometers, this is the cruising altitude for most passenger jets. As you go higher into the air, your ears might pop due to the rapid change of air pressure. The high pressure air in your inner air is trapped for a while, so you feel quite uncomfortable. However, if a plane incident happens, then you will faint, as air pressure outside is only 3 psi, which is only about 23% of the air pressure at sea level. All the things you just witnessed above are in the first layer of the atmosphere, called the troposphere. Isn't it amazing how big our atmosphere is? The troposphere, as your science teacher has taught you, extends to 9 kilometers above at the poles and 17 kilometers high in the equator. The reason behind is because the atmosphere also has this property. It is thickest at the equator and thinnest at the poles. Most of the atmosphere's mass, about 75% to be exact, is in the troposphere. All the weather happens here, and all clouds form here. Supercell clouds can rise as high as 16 kilometers, which is the boundary of the troposphere. Water vapor rises high into the troposphere and forms clouds. The greenhouse effect also happens here. Small planes fly near the upper boundary of the troposphere. Thank you for watching this video. If you enjoyed, please subscribe and smash the like button, as it will help out your boy a ton. Apart from that, you will also be granted 10 years of amazing luck and educational content. Go check out the other amazing videos on my channel, and I'll see ya!